Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a very exponential equation with complex numbers. E to the power z is equal to e. Are you coming from my other channel, Cyber Math? If not, then go ahead and check it out because I do algebra, number theory, and trigonometry problems. I'm hoping to do a geometry problem in the near future. All right, great. So let's go ahead and take a look at this problem. Well, isn't this obvious? You're probably asking at this point. I would say yes and no. Remember, we are in the complex world. And if you're new to complex numbers, go ahead and check out my lecture videos because I go over the basics of complex numbers. If you have any suggestions, always let us know in the comment section down below. If you have questions, comments, suggestions, anything you want to say, write it down. Go ahead and share with us. So first, we're going to go ahead and complexify the e on the right-hand side. What is that supposed to mean? Again, if you're new, check out the lecture videos. But I'll explain all that is. Okay? First of all, where is e? How do you graph it? On the argand plane, which is the complex plane, right? Well, e is right here because it's a real number. It's going to appear on the real axis and not on the imaginary axis because the imaginary part is 0. So it obviously is e units away from 0, which means its modulus is e. And also considering the angle, right, measured in the positive direction or negative, doesn't matter. It looks like 0 radians, or I guess we could write it as 2 pi, or 4 pi, or 6 pi, or negative 2 pi, or any multiple of 2 pi. You get the idea? So we can write the e as e times e to the power 2 pi ni, which is 1 in the complex world, and that kind of explains it because it's supposed to be 1, right? So in general, z, which is a complex number, can be written as r times e to the I theta, where r is the modulus, aka absolute value, and theta is the argument or the angle we just talked about. In this case, the argument is multiples of 2 pi because there are multiple values. That's why we have the multiples. And we just have to multiply the theta by I to get the polar form. Thanks to Euler, we have what is called the polar form of a complex number. Okay? So at this point, you could probably say, okay, I think this is a solution, but think about it, hold on to it, because we can check that at the end. What is that obvious solution? I don't want to name it, and don't tell anyone if you know it. Okay, so here's how it goes. We have e to the z, which is equal to e, and now I can write it as e times e to the power 2 pi ni. Wait a minute, e means e to the power 1, so I can add the exponents. By the way, n is an integer, before I forget to say that. Okay, now we can go ahead and combine the exponents, write it as e to the power 1 plus 2 pi ni. And then we can kind of natural log both sides and just check the exponents. They are supposed to be equal, right? Well, kind of, right? I mean, could we not multiply by e to the power 2 pi ki? You don't need to because we already did. Makes sense? So you can go ahead and do this. E to the power z is equal to 1 plus 2 pi ni. And you don't really need to add another. Do we need to add one? I'm not sure. I don't think so. But if I missed it, let us know, always. So we got this equation, which seems to be a little simpler than the original one, but it introduces new complexities or complications. Why? Because 1 plus 2 pi ni is a complex number. Okay? Let's go ahead and write it in polar form. Again, thanks to Euler, we can do that. Let's go ahead and set w equal to 1 plus 2 pi ni. By the way, I'm not talking about Lambert's W function here. W is just another complex number. But if you like Lambert's W function, go ahead and check out my other video on my other channel, which is Cyber Math. And Cyber Math with an S. Okay? Maybe you came from there and you already know what I'm talking about. Anyways, back to the video. W is equal to this. Now let's go ahead and set the argument of W equal to alpha, which means that tangent alpha is, remember, if you have a plus bi and argument is whatever, tangent argument of a plus bi is b over a. Why? Because if you graph it in the complex plane, you're going to know what I'm talking about. But that's what it is. So tangent alpha is 2 pi n. Don't include the I because it's not part of the formula. Okay? So this is my tangent. What does that mean? Under certain conditions, I have to be very careful. Alpha can be written, sometimes, as arctangent 2 pi n. Why do I say that? Check the quadrants because it's not always the case. But let's just simplify things because this is kind of complicated, okay? So we got to keep it simple. You agree with me on that? Okay. Say n is equal to 0. Haha. That means alpha is arctangent 0, which is 0, because if you think about it, tangent 0 is 0, right? But wait a minute, isn't tangent pi is also 0? But tangent pi, yes, tangent pi is also 0, absolutely. But the thing is, it's not the only angle, or it's probably not what we're looking for. Anyways, so alpha is equal to 0. The problem is, it's impossible. You know why? Because if alpha is 0, then what's going to happen is, wait a minute, why is that impossible? Okay, let's check it out. So if alpha is 0, let me check something because I think I found something. That means n is equal to 0. Actually, that's possible. Why did I say it's impossible? I don't know. If n is 0, e to the z is going to be 1. Okay? And that means z is 0. Yes, z is 0 is going to work. And you probably guessed that, didn't you? But guess what? It's not the only solution. That's why this problem is interesting. Anyways, now say n is equal to 1. Right? And then from here, alpha is going to be arctangent 2 pi, which is about 1.41 radians, or 80.96 degrees. So it's a big angle between 0 and 90, but it's closer to 90 because its tangent is, think about it, 6.28 something. A pretty big tangent. So you kind of need to draw a right triangle that is pretty steep, right? So now let's take a look at the absolute value of w, which is the absolute value of 1 plus 2 pi ni. By the formula, it's the square root of 1 plus 4 pi squared n squared. And obviously, this is greater than 0. And now we can do the following. 1 plus 2 pi ni can be written as r, remember the formula? Times e to the power I theta, and theta happens to be arctangent 2 pi n. And of course, we're going to set it equal to e to the z. And if you apply natural log on both sides, you're going to get the following. Are you ready? ln square root of 1 plus 4 pi squared n squared plus I times arctangent 2 pi n, where n is an integer. And if n is equal to 0, ln 1 will be 0, and you'll get z equals 0, which is definitely a solution, right? And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.